I'm going to talk about the graphing of all variations of the secant and cosecant function. If graphing sine and cosine is in your comfort zone, then this is not going to be very much of a stretch at all. So, to graph secant of any kind, we graph, what I want to ask you to do is write down the associated function. The associated function. The associated function is g of x. Don't write f because it's a different function. G of x is 3 minus 2. Secant is associated with cosine. Cosecant is associated with sine. The reciprocal function. And now go through the same four-step process to graph out this function, except graph this as a dotted line. All right? So we have the basic shape. And you don't need to, but I always like to do this. See, this is negative cosine. It's negative cosine. I like to go ahead when I'm doing the associated function to remind myself that needs to be as a dotted line. You don't need, if you want to make that solid, that's fine. But this is a good habit because this reminds you that cosine is dotted. Cosine is not what we're after. This is the stepping stone to get to secant. So there's the basic shape. And then we have the amplitude. This, I hope, is becoming a little bit old hat by now. This is absolute negative 2, which is 2 if you like. Vertical shift. Shift, make sure you spell that correctly, is vertical shift is there's up 3 because we're adding 3, right? The fact that this is up is not because this negative goes with the number behind it. This is a plus 3, and so we're shifting up 3 units. And then the basic interval the basic interval, there's no change. So this is 0 less than or equal to x less than 2 pi. So there's no change to the basic interval. All right, so I'm going to draw my graph over here. I need to shift up a little bit. So shift up 3 units. 1, 2, 3. So this is 3. That is now the midline axis. This is a very important notion coming up here. This is the midline axis. All the nodes are going to be on that dotted line. They're going to be on that line. The amplitude is 2, so we go up 2 to 5 for the peak line, and down 2 to 1 for the trough line. Now we need the horizontal scale. So this is 3. See my compass here? This is 3, that's 3, and a little bit more makes pi. If that's pi, that's 2 pi. And that's what we want, 0 to 2 pi. So here's one sideline, here's the other sideline. And I need to make this. And here, look, see, this reminds me, this is a dotted line. And so I have trough. Oh, I need my little pi over 2 here. Pi over 2, 3 pi over 2. Trough, node, peak, node, trough, but this is a dotted line. See the reminder? Otherwise, you're liable to forget and just draw that graph and be done with it. We're not finished. This is anything in the picture which is dotted is considered not part of the graph. You can make as many dotted line sketches here as you like. They are not part of the graph of this function. Anything that's dotted is considered not part of the graph of this function. They're just assistants. There's a skeleton, if you will, the framework that we're going to hang this function on. And so now, once we have the associated function graphed, now we need to find the vertical asymptotes. And here's the important piece. The vertical asymptotes do not occur at the x-intercepts. The vertical asymptotes occur at the nodes. Vertical asymptotes. Vertical asymptotes for secant of x and for cosecant of x. The vertical asymptotes for secant of x and cosecant of x occur at the nodes. Occur at the nodes. That's why that terminology is so important. Anywhere there's a node, we need a vertical asymptote. There's a node, we need a vertical asymptote. Now the question is, how do you know which piece is above, which piece is below? You know the points of tangency. So this is a point of tangency. So after that, just sketch it in. Here's a point of tangency, so this is above. Here's a point of tangency, this is below, and that's my graph. So sketch in the associated function graph of cosine or sine, and then find the vertical asymptotes at the nodes, and then the points of tangency tell you whether you need to be above or below. All right? So I think if we play one more, we'll do one more here with secant, and then anything else is the same variation on the same basic theme as we've been doing all along. So here's this. I'm going to go ahead and see if I can do another here. And the one I'm going to see if I can work on, let me check my list over here to the side. Okay, I'm going to say, I'm going to do f of x is equal to, let's go -2 plus cosecant of 2x. And so what do we have here? First, we have the associated function. The associated function for cosecant, right, this is g. Some other letter. If this is g, make this a different letter. If this is g, make this f. Or if this is g, make this h or j or k. Just make it a different letter. But everything else is the same. We have -2, but this needs to be sine of 2x. And then we sketch the graph of -2 plus sine of 2x, dotted line, as the structure, the stepping stone to get to the graph of cosecant. So now we go through our same four-step process. We have the basic shape. Basic shape is positive sine. And again, I'm going to emphasize dotted, sorry, my sign's backwards here. Right, dotted line. We have amplitude. Absolutely, the coefficient is 1. So the amplitude is 1. We have a vertical shift. Of, looks like we're going to go down 2 units, down 2. And then we also, see this is not just x by itself, we're also going to have a change of the basic period. So the basic period, is we take 0 less than or equal to is less than 2 pi. In the middle, put this argument, solve for x. In this case, that means everybody gets divided by 2. And so we get 0 less than or equal to, the 2's cancel, x, which is less than the 2's cancel, pi. So that's the basic interval. Actually, we'll go ahead, we could use the or equal to, but that's all right. And then sketch in, let's see, I'm going to shift down 2 units, so I'm going to kind of put it up here a little bit. We shift, vertical shift down 2 units, so find the axis at -2. This is now the primary axis, the central axis of this graph. The amplitude is 1, so the peak line is at -1. The trough line is at -3. All right? And now we need a horizontal scale. So if this is -3, that's 3. So this is 3, this is 3. A little more, that's pi. If that's pi, that's 2 pi. But let's see. Oh, I only need from 0 to pi. That's good. So I only need from 0 to pi. I don't actually need this 2 pi over here. So this is the right-hand side. This is the left-hand side. I do need to divide this into 4 equal pieces, and we should be used to that by now. This is pi over 2. This is pi over 4. If this is 1/4, 2/4, 3/4. Right? Easy money. So now I need to take this basic shape, dotted line, see my reminder? Dotted line, sketch in those 5 basic points. Node, peak, node, trough, node, dotted line. See how the dotted line helps with the associated function? And now we need the vertical asymptotes. So the vertical asymptotes, anywhere you have a node, there's a vertical asymptote at 0. All right, I can see if you make your lines at a slant, it helps to show up on the axis. Vertical asymptote at pi/2, vertical asymptote at pi. And wherever you have a peak, that's where the point of tangency happens. Anywhere you have a trough, that's where the point of tangency happens. And for our purposes, that is more than enough. So I think if you can graph the sine and cosine, then graphing the associated cosecant and secant graphs should not be too much of a hassle for you.